Alright, we are going to talk about VORs. VORs are a topic that is a big struggle for a lot of students. It was a big struggle for me when I was a student, but we're going to talk about them. Okay, so we're going to go over how they work a little bit, right? What they are, what they look like, and how do you use them to your advantage as a pilot, because they can help you a lot. Okay, so a VOR stands for a very high frequency omnidirectional range. Very high frequency, that's the V, and then O is omnidirectional, R is range. Okay, VORs are a ground-based navigational facility. Ground-based meaning it's located on the ground, right? It's not in the air. Your plane has a GPS in it, okay, and that GPS helps you navigate, but it uses satellites. VORs are older technology that are on the ground. Okay, VORs are located all across the country, and you can see them on your sectional chart. For example, there's one right here. The way you'll notice a VOR is by this symbol, and this symbol is a VOR DME. We'll talk about that in a little bit, but it's this symbol with the dot and then this little shape around it. Okay, the box indicates DME, but this symbol right here is VOR. Again, talk about the DME in a moment. That symbol is always going to be surrounded by this compass rose. Okay, this compass rose looks very familiar to your class Delta airspace right here. It looks pretty similar, but it's different. The compass rose is how you find a VOR. Now, on Long Island, where you're flying, right, you have one right here. This is called the Deer Park VOR right here, because it says it right there. We have one over here, surrounded by this compass rose. For some reason, Calverton doesn't have the symbol. I think because it's on this old private airport. But there's one in Calverton. There's one out in Hampton. All right, there's one in Madison. VORs are these compass roses. Now, the reason we have these is primarily for IFR traffic. So IFR traffic, instrument flight rules traffic, are the planes that can fly without seeing outside, like your airliners. And if you want to get instrument rated, you'll be able to do that. So the IFR planes, they use VORs to navigate to different points around the country. Now it's not letting me pull this chart up here. There we go. This is an IFR chart. Now if you notice, this one is almost easier to decode than a VFR chart because it kind of makes more sense, right? It has highways in the sky. These highways are called airways, right? Federal airways, okay, these black routes that connect VORs. So the principle we use here is, you know, if you fly to the the Deer Park VOR, then maybe to Calverton, then to Hampton, and all the way up here to Providence and Boston, you can navigate without being able to see. Yes, you may be saying, all right, you know, that kind of makes sense. Why is it on a VFR chart? Right, that's a great question. The reason we have them on VFR charts is because we could use them to our advantage, right? If the IFR people can use them, so can we. If we want to conduct a flight from Farmingdale, maybe up to Albany, maybe nighttime, right? When you're flying to Albany at nighttime, you really can't see much. It's dark. There's not a whole lot of, city area here. It's just trees and some small hills and mountains. But you could fly from Farmingdale to Deer Park, then you can go to Carmel, then you can go to, I think this is Kingston. You can bounce between different VORs to help make your way to Albany. Okay, now these VORs, a very important thing about them is their line of sight. So your plane can only pick up the signal, okay, if it can see it. Now these VORs have different service volumes, which is too advanced for your level right now. But basically, if you're far away from the VOR, you're not going to get it. Right? Every VOR is different in service volume, so I can't tell you an exact number. But generally speaking, most of the ones we see here, you'll see about 40 miles, but every VOR is a little bit different. Now, so to get into the science behind these VORs, we just discovered that we can fly from VOR to VOR, kind of bounce between them, hop around them, and get to where we want to go. We've got to understand what they do. Right, so if I go into here and I draw a little VOR, say I draw this symbol right here, like that. And let's call this the Deer Park VOR. So my drawing is going to suck on here with my mouse, but I'll try my best. So this Deer Park VOR, alright, it has a frequency associated with it, right? Because it's a very high frequency on the directional range. Okay, just like on your radio, you would tune into, Republic Tower or Republic Ground. You're gonna now tune into the Deer Park VOR. Now, this frequency I'm talking about is located right down here, 117.7. Okay, you put that on your nav radio. We have the comm radio. Now you have your nav radio. And in a little bit here, I'm going to show you how to do this, but I'm just explaining. You put that on your navigational radio. Okay, so Deer Park has frequency 117.7. And most importantly here, what does this thing do? Okay, it transmits these signals. Picture them like, I don't know, whatever you, kind of like a Star Wars, like one of those, what are those things called they used to use in Star Wars? I'm blanking right now, but I think you know what I'm talking about. These light beams that kind of point out, right? These signals. Now, these signals that I'm drawing out are called radials. Okay, it transmits radials away from it, not into it, away from it. Okay, now I only drew a couple here, but these radials, it transmits them in all 360-degree directions. So, if I just search up a compass rose here, I'm sure you're familiar with it. A compass has 360 degrees in it. So if you take a look, this one should work. Here we go, right? This is a incorrectly made compass. That is not right. Here we go. So this compass has north. It has 10 degrees, 20 degrees, 30, 90, 180, 270, all the way back to north. Okay. But you could even go 001, 002, 003, 004, all the way to 360. So these radials that I'm drawing out here go in all directions. Now I'm not going to draw out all 360 of them, but that kind of get the point there. Right, so these radials, they're labeled, or they're called the direction they face. Right, so this one right over here, this one is called the radial 0, 9, 0. Okay, because if you look at this compass rose, here's east, this is 80, this is 100, so this is 90. It's the 090 radial because it goes this way. It's not going this way to 270, it's facing 090. With this logic, right, this radial, I lost my mouse. Where'd it go? There we go. This radial is the 360. This radial is 045. This is 135. 180. This one's going to be 215, I believe. No, 225 rather. 225. 270. And while I'm doing this, write this stuff down as well. This is 300. Yeah, 300. So your aircraft has a navigational radio. Okay, and it has what's called a CDI, a course deviation indicator. So CDI, I'm sure you've seen this and have wondered, what the heck is that thing inside of my cockpit? Right, this little guy right here, CDI. Okay, you're going to use this to navigate to your VOR. This is the ones they kind of use in the written, I believe, or something like that. Okay, you're going to use those two things, your navigational radio and your CDI, to navigate to. So when you tune in 117.7, I think I wrote 117.1. When you tune in 117.7, your plane can pick one of these radials up. Okay, so let's say, for example, your airplane is located right here on the 270 radial. I'll draw a little plane here, line. Boom, here's the plane. Okay, your signal, your plane, will be able to navigate you directly to the VOR on the 270 radial. And then when you cross it, you could fly the 090 radial, you could fly 045, heck, you could fly 073. It doesn't matter. Okay. You could use these radials to help find airports. For example, if you look at the map and you look at Deer Park and draw a line from Deer Park to Farmingdale around this compass rose here, you could say, Farmingdale is located on the Deer Park radial 250. I'm just guessing, just looking at it. So if I fly the 250 radial off Deer Park to Farmingdale, I'll find the airport. If the weather's that bad, you probably shouldn't be flying. But, worst case scenario, you could use it to help you. So, I mentioned we have these things called a CDI, right? So I'm going to draw one of these things. Okay, here it is. Got the numbers on top, these little marks with all your numbers. These are just a couple of numbers. Okay, so the way to do this, and I'm going to show you in a flight simulator here in a second, but I'm going to draw it on here first and write this stuff down. So the first step when tuning a VOR is tune, right? Tune it in. Like I mentioned earlier, just as you would tune in the frequency for Republic Tower, you're going to tune in the frequency for Deer Park VOR. So in this case, you put in 117.7. And we're going to go over how to do this on the simulation. So you tune it in. The next thing you have to do is ID it. There are so many VORs across the country. Okay. Everyone has a slightly different frequency. Some of them share same frequencies, but you got to be in range to hear one or the other. You have to be able to know, okay, when I put in 117.7 in my navigational radio, is that the right one? Okay. So if you notice, next to this little VOR box here for Deer Park, it has this Morse code. Now, you're not supposed to know how to, decipher Morse code, but your airplane is going to play this signal. And this represents sounds. This is a longer sound. This is a shorter sound. Short, long, long, short, so on and so forth. Same thing up here with Calverton. Now, this spells out Calverton, right? C, C, C. Deer Park spells out DPK. You have to sit there with this Morse code in front of you and verify, okay, that's the correct one. Now, this is going to involve going on your audio panel and selecting either Nav1 and or Nav2 to hear this Morse code in your ears through your headset. So, once you have identified the VOR, you have to twist it. Twist what, you ask? That is twisting the CDI. CDI, right here, CDI is a course deviation indicator. You may hear me call it OBS sometimes, Omni Bearing Selector. Same concept, right? You're just selecting different bearings to the station in the omnidirectional range, all 360 degrees. So, what you're going to do is you're going to go ahead and twist the CDI. All right, I lost my mouse again. There it is. There's a little knob right here. And twist it until this little needle comes in the center. The needle's going to center up right here. And again, just to show you this needle that I'm talking about, let's go back to images, is this guy, this one. For VOR navigation, don't worry about this one. This is for IFR flying. Tune that out. Okay, so this needle is going to come center. You have to twist the knob until the needle's centered, and the flag right here is pointing up and it says 2. Okay, so like in this picture, this is this little flag here, it says 2. This one says 2. Okay, now once you do that, there's going to be a heading on top. Like in this one, it looks like it's north, right? 360. Again, 360 is north, right here. 360. Let's say in this example it said 090. So what this CDI here is telling you is that if you want to get to the station, right, to Deer Park, if you want to get there, you have to fly a track of 090. Okay, here's your plane. If you want to get to the station, you have to fly a track of 090. That track, that thing I mentioned, it's a bearing. A bearing is the heading or the track you have to fly to the station. Now, the reason I use the term track, if you fly a heading 090 and the wind is coming from the south that day, it's going to push you off course. Okay. Now, if we want to get into deeper of what this is really telling us, this CDI, it's really telling you that, yeah, you fly 090, that's going to get you to Deer Park. Okay. But in reality, what this means is you're actually located on the 270 radial. Okay, so here's this radial right here, 270, circle it, 270 radial. So let's just go out for miles. Okay, your plane is located on it. Okay, so on the bottom of your CDI, it's going to say 270. All right, that's what that means. So you're going to fly along, And now, if you've been doing written prep, you know that typically, once you get within about a half mile or so, within the VOR, you enter what's called the cone of confusion. Think of it. If the VOR is shooting out these signals, right? Basically, not to get too advanced, a VOR sends out two signals, okay? It compares the difference between when it intercepted your plane versus the other signal, because again, it sends a signal out and your plane receives it and shoots back information. Okay, it can only do that when it can see you pretty well and you're a good distance away. Once you get over it, you're getting so close to all these radials, it loses track of where you are. It has no idea. Okay, so this little line here, this needle we call it, will start moving left and right. Okay, now, once you cross Deer Park and now you're over here on the other side, still going this way, this flag here, erase it from your memory. Let me see if I can do this. That flag, once you cross, is going to go away. Okay. It's going to now say from. I'll explain why in a second. There we go. Whoop. So we're going to still have 090 on top. Okay, 270 on the bottom. But now it's going to be pointing this way. It's going to say FR. Because this is telling you that 090 is taking you from the station. It's taking you away from the station. Meaning you are located on the 090 radial. Okay? This needle always points to the station. Right? If your plane is here, going this way, it tells you, yeah, 270 is going to take you back to the station. You have to turn 270 to get to the station. All right. Now, in a perfect world, that needle never moves. Okay, but we're not perfect. Nobody's perfect, right? Let's assume, hypothetically, we're on the 090 radial going this way. Okay, we're flying along. Here's your needle. Whoop, that's a very sloppy needle. Right here. A little better. Your CDI will have 4 lines that show course deflection. Each one of these lines is 2 degrees off of course now. Here we go. 2, 4, 6, 8. Right there. 2, 4, 6, 8. Okay. Hypothetically, if your plane is here, let's say you drift off course. You start flying this way. Alright, you drift off course, now you're over here. You still have 090 tuned in. Okay, you have 270 on the bottom. Very bad drawing, I apologize. It's going to say from. This needle is no longer going to be centered because, think of it, you're not on that radial anymore. You're not on the 090 radial. You're physically off of it, right? Picture it almost like a street. If you turn off the street, your GPS is going to show you that you're not on the street anymore. Well, assuming your phone works. Okay, what's going to happen to this needle now is it's going to shift. Right, take these lines away. If your plane is located to the over here, the left, of course. Say it's right here. This needle will now be over here. Okay. Inside your CDI is a little circle. People call it the donut, right? Where is it? Looks like this. That represents where your plane is. This circle is where you are. This line represents where your desired radial is. You put 090, it said from, so you're tuning in this radial. It says, yeah, you're here, okay? But the radial you want to be on is over here. Now, I see I made a critical mistake here. If we're left, of course, the needle is going to be over here, okay? Here's the donut. That's your plane. And here's your desired course. Now, think about it, right? If the donut is you, here's your plane, you want to be on the 090 radial right here. 090 from flag. Let me redraw that. The from flag, that is to the right of you. You are left, of course, the needle is to the right. It's deflected to the right because you have to turn to the right to get it. So let's say you turn back in. Okay. As you get closer, this needle is going to move here, and then it's going to come in center. Now, let's see if I can expand here a little bit. Let's see if this makes sense. So let's assume your plane went so far off a course, you went over here. Now you're flying this way, right? Maybe go over here. You're right here. You had 090. Needle's so far deflected to the right, it's right over here. You are not on the radial anymore, so you go, screw this. Let me just recenter my needle. So you twist your little knob here. Keep twisting, you twist and twist and twist and twist them. Eventually, you get to a point where on top, it no longer says 090. It says 045. Centered. Oop. Hopefully not like that. It's centered with a from indication. Meaning, yeah, your plane now is located on the 045 radial. When you're tracking these radials, when you're flying these radials, right, whatever heading your plane is flying, you should have that on the top of your CDI. Because if you don't, you're doing what's called reverse sensing, okay, which is not good. This is where it gets a little too advanced, but I'll try to explain it now, okay? We just discovered that our plane is now on the 045 radial, away from the station. We use this terminology called tracking outbound, right? We're tracking this VOR outbound, away from the station, okay? But if you notice, if 045 takes you away from the station, you could fly 225, right, going this way, to get to the station. So, if you put 225 on top, 225, okay, this needle is now going to say 2. Because it always points, the needle always points to the station. Okay, 225 takes you to the station. If you want to fly on the 045 radial outbound, okay, put 045 on top. If you put 225 on top, your CDI will not indicate correctly. It'll be what's called reverse sensing. Alright, let's see if I can... How big is this eraser here? Yeah, it's way too small. Let's keep clicking this. I want to just do one more example, then I'm going to show you in the plane how to really do it. That's as far as it goes. Let's say our plane is here. Right here. Here's our plane. Traveling northbound. Okay. I screwed it up. Am I able to fix it? Huh. Ah, finally. That took me 20 minutes. So, let's say your plane is up here, traveling northbound. If you put in Deer Park and twist your needle till it centers up, and it says 2. Let's think about this. I want you to pause the video and ask yourself, if your plane is located here, flying to the station, tracking inbound, okay? First of all, what radial are you located on? The answer to that is the 180 radial. And the second question is, what heading will appear on top here once this is centered up with a 2 indication? The answer to that is 360. Okay? Because although you're on this 180 radial, 360 heading or track takes you to the station. So on the bottom here will be 180. If you twisted this needle around and you put 180 on top and our plane's still down there and 360 on top, it's going to now say from because it's pointing to the station. So it would be unwise of you to fly to the station with your CDI set like this because you're not flying a heading of 180. You're flying a heading of 360. Again, back to the compass rose. You're flying a heading of 360. The term reciprocal means that if you fly, reciprocal means the 180 degree opposite, just the U-turn direction of a heading. So for example, the reciprocal of 090 is 270. The reciprocal of 360 is 180. It's just the exact opposite, right? The other direction in 180 degrees. Okay, so we figured out kind of sort of how this works, right? It has radials. Your plane can pick up these radials and navigate on them. Your course deviation indicator will show your course deflection off this VOR, whether you're on it or you're 2 degrees or 4 degrees off. That one is. This one's like 5 degrees off. Okay. Now we're going to go over how to do it in the plane. Okay, so we're going to go open. Don't save that. I'm going to go open up Sim here. Don't want to do that. Assume that. So we're here at Farmingdale. We're going to go ahead and take off in a second. Make sure everything's good with this. We're going to go ahead and do some work with the Deer Park VOR. So I'm going to go ahead and take the plane off here. And we'll just fly it towards the east, towards Deer Park or so. And we're going to start tracking some VORs. Now, on the ground, the concept's pretty simple. In the air, it's pretty simple as well. It just takes some getting used to see, okay, how do I actually apply this to my real world flying. So I'm going to take off. They're going to climb to about 1,000 feet or so, and we'll get going with this. Nice morning here at Farmingdale. Alright, I'm going to make a left turn to a heading of 090, which is an eastbound heading. Go ahead and level the airplane off here at around 1,000 feet. Okay. 090. Set my trim a little bit. Alright. just delete this yoke. Set the throttle up a little bit more here. Try 2300 RPM or so, 23, 24. Alright, plane is flying approximately well. Alright, so let's get into it. The first thing we're going to do is tune in the VOR. So, if I go back to my chart here, I saw that Deer Park is on 117.7. So, I'm going to do that. Go to my radio here, and I'm just curious, if I pause, can I still twist this? Aha, I can. So I'm going to pause it just to really show you. This unit is called a Garmin 530 GPS. This is the Garmin 430, which is mostly what you're used to, right? We're going to use both. So, on the top here you have COM, the bottom is your nav. Same thing with the 430. COM and nav. This term VLOC, the V stands for VOR, which is what you're doing. The LOC stands for localizer. Those are for IFR planes, not for you. Don't worry about it right now. So, the first thing is tune. To get from the COM numbers, because right now we're messing with the COM numbers by moving this knob. To get from the COM numbers down to your nav numbers, your navigation radio, press this in. Push COM or VLOC, CV. So see how when you push this, it changes the shaded area from COM to nav. Next thing is dial in 117.7. Switch it into active. Okay, this is standby because it's not inactive, it's standing by. Switch it into active by pressing this button. Okay, there it is. Now it's tuned. Now we have to ID it. Okay, so the way we do that is we move our little volume knob here. Looks like it's all the way up. And it says push ID. See right there? Push ID. You push it in. Okay, and in the real plane it's going to say ID right here. And then you go on top to your audio panel and you move this down to listen to it. Now in the sim I don't think it plays it, but in real life you're going to hear that Morse code for Deer Park. Again, just to remind you. 117.7, and you're going to hear this Morse code. So, once you identified it, you go ahead and push this back in and go on top of your nav 1 and turn it back off. Right? Obviously, most of your audio panels don't look like this, but you're just going to press nav 1 to hear it. Next thing is twist. You're going to twist this until it centers up. Okay. However, the most important thing is to realize that your CDI, the first one here, this is called CDI 1 or nav 1, call it, also can get information from your GPS. So you have to make sure that it's in VLOC mode. So you're going to do that by going on your CDI, your GPS right here, and pressing the button that says CDI. So when you press it, this is going to say VLOC, because it's in VLOC mode, it's going to be in white, and most of your CDIs will tell you. So, you twist this, just moving this knob, until this needle comes alive. Oh, there it is. It says 2. Okay, I'll show you what it says if it says from. We'll just twist it just so you can see both sides. Here's from, centered up. There it is. Okay, you're going to center it until it says 2. And the heading on top is your bearing to the station, right? This is 030, this is 040, this is 050. So the arrow is saying about 052. Alright, now to help you visualize this, we're going to go back to our little drawing here. I believe I had it open down here, maybe not. Let's open it back up. Here it is. Here's Deer Park. Let's say Deer Park's this circle. This is the radial we're located off of. Our plane is right here, flying this way. So, the way we know what radial we're on, well, if this says 2, and this is the heading on top, the radial is the heading on the bottom. Let's see what heading that is. 210, 220, 230, about 235-ish, give or take. So, this CDI is telling you you are on radial 235. Okay, you are on this radial going to the station because, you know, it says 2, 05, you know, whatever, 055. Okay, now if I put in, say I put in the 18, well, let's make it a bit easier. Let's say I put in the 210 radial, which is about here. Okay, our CDI is going to move. So the way I do that, okay, is if I just leave this flag as 2 and I put 210 on the bottom here, right there, 210 on the bottom, and it says 2, meaning this is the radial because it's on the bottom. If you have a 2 flag, the number on the bottom is the radial. The number on top is the bearing. Notice how your needle here, your course deviation indicator needle, is off to the right. Which that makes sense, right? Your plane is here, but the radial you selected is off to the right. The radial selected is off to the right. Alright. So, let's recenter this. We tuned it, identified, twisted it. Now we're going to track it. Alright. So let's unfreeze the sim. Again, it tells me if I fly, what does it want? Pretty much 050 now, I will get to the station. Now, in the sim right now, we have 0 wind. Okay. So a heading of 050 will work. But in real life, we typically always have wind. So we can use GPS track to our advantage, which right here, see how it says track 050 on the bottom, 051 on this one, okay? You'll fly a track, because if I fly a heading and the wind pushes me off, now I'm off my radial. So now I'm navigating to the station. I'm flying 050, I'm on the radial 230 now, it seems like, and I'm flying to the station. Now, this CDI, the CDI, doesn't take into account your aircraft's heading. It does not. It's only taking into account where your navigational radio is located relative to the VOR. So it can tell you, yeah, you're on the 230 radial away from the station. Okay, but that's all it can tell you. Just to see, here's Deer Park VOR. Here's that far. And this is where we are, away from it. Okay. Just to show you, I'm gonna make a really sharp turn here, just to face the complete opposite way, and I'm gonna show you that nothing is gonna change on your indication. Now it might move a little bit, right? Because I turned away from it a little bit. But let me just recenter this needle here. Nothing changes. It still says, yeah, this heading will get you to the station, right? If you turn away, it doesn't know that. It just knows, okay, yeah, there's your CDI. You have to tell yourself, wait a second. 035 takes me to the station, but I'm flying 225, right? I'm flying down here. I'm flying away from the station. So if I wanted to track this radial outbound, I would have to put the heading that I'm flying. Now it says from. Boom. There I am. 225 radial going away from the station. This way. Here I am. Talk about 2 more things. Next thing is called DME. DME is called Distance Measuring Equipment. If you have a VOR like this, the circle, if the VOR has a box around it, it has DME. If you look at Deer Park, there's the symbol. I'm tracing with my mouse. There's the dot. This box shows DME. DME uses what's called slant range to find you. So if this is your VOR station on the ground, and this is you say you're at 3,000 feet. It simply just shoots a signal from the VOR to your plane, and it measures this distance. It does not measure this distance. It does not do that. It measures slant range. So keep that in mind. There's a thing called slant range error you'll learn of, where if you're over the station at, say, 6,000 feet, that's about a mile. Right? A mile is 5,280. So your DME is going to tell you, yeah, you're a mile away from the station, so even though you're not, so you have to be aware of that. Okay. Alright. Now, most planes don't have DME units anymore. Some of our planes do. Okay. That's why we'll use GPS DME. The way we could do that is by scrolling this big knob, but I'm going to make a separate video of how to use this GPS, right? Well, if we scroll this big knob here to nearest VOR, Deer Park is 5 miles away, right? That isn't measuring slant range, that's measuring your actual distance of where your plane is located on the ground to where it is. Now, if you're far enough away, it's about the same thing, right? This guy right here, this unit, it says DME. This is an actual DME unit. If you put in the frequency of 117.7, which let's put it in, 117.7. 4.9 miles. This says 5. Yeah, they pretty much agree because we're far away. This is what a physical DME unit looks like. So DME is distance measuring equipment. It measures in slant range how far you are away from the VOR. Okay, the final thing we're going to talk about. I know we were talking about so much today. I'm sure half of this makes sense, half of it doesn't. It's okay. The first time it's probably not going to make sense. The last thing we're going to talk about is this concept called VOR triangulation. Alright, which is to be used when you're lost. Now, they always say it's virtually impossible to get lost on Long Island, which I've been flying here for a couple of years. It's very hard to get lost on Long Island. If you ever fly in an area away from home and it's dark and there's trees everywhere and you can't see the ocean or the Long Island Sound, you might use this concept. So this concept of VOR triangulation is to be used when you're lost. Okay, so let's go ahead. We have 117.7 in here. Let's tune it in, or let's twist it to get a 2 indication. I'm located on the, let's see what radial I'm on. Approximately 200. See how it's 2, so the number on the bottom is 200. Okay. So if I go ahead and draw that, here's the VOR. Radial 200 is approximately here. I'm somewhere along this route. And now if I'm lost, I could tell myself, okay, I'm somewhere along that route. Now, that's helpful, right? But let's say, you know, picture it like New York City. Okay, I'm sure you guys have been there. If you're lost in New York City and you see a sign that says, "Oh, okay, you're located on 5th Avenue," a pretty famous street. You're gonna tell yourself, "All right, great, I'm located on 5th Avenue, but where am I? Down here in Tribeca, or am I way up here in Midtown?" You have no idea. Right? You just know I'm somewhere along this street. Right? You know I'm somewhere on this radial 200. It would help you if you looked up and said, "Okay, yeah, I'm on 5th Avenue, right? I'm on 5th Avenue, and this sign here says 53rd Street. I'm on the intersection of 5th Avenue and 53rd Street, right here." You could pinpoint that and go, "Dang, I know exactly where I am now on Manhattan." So if you could use a separate VOR, maybe Bridgeport, BDR, and find out what radial you are on from Bridgeport. They intersect right here. That's where I am. Let's do that. Okay, so we go back to our thing here. Or just the power bit so it's less loud. If it makes it easier for you, just for you to understand, I'm going to twist this needle for it to say from. So the heading on top is 200, like we said before. Okay, 200 is from, so it's the radial. Needle points to the station. 020 takes you to Deer Park. Let's tune in Bridgeport. So you go to your sectional chart and find Bridgeport. To find Bridgeport, you just look for Farmingdale, go to the Northport Stacks, go across the sound to the northeast. There's Bridgeport. Bridgeport is a Class Delta airport surrounded by this huge compass rose because they have a VOR on the airport. Bridgeport VOR 108.8. So in this plane, I go over here, my nav2. Press in. Tune in 108.8. I switch it into active by pressing this button. This button switches the comm numbers. Right? Just change them, yep. Switches the comm numbers. This one switches your nav numbers. 108.8. Turn my volume. Yep, it's already up. Push it to ID. And select nav2 on the audio panel. Okay. So now we have Bridgeport tuned in, and we are IDing it. Alright. So, now I have to change my CDI to VLOC, and I go down here. And I twist it until it centers up to or from. Since I'm looking what radial on, I'm probably just going to do from. And it says that I'm on, looks like the 210 radial off Bridgeport. Alright, let's take a look. Now I realized I kind of drew this incorrectly with the locations. If this is Deer Park, DPK. If we look at our map here, Deer Park, Bridgeport's to the right of it. Bridgeport is over here. So I'm on 200 off Deer Park. And I'm on, I believe it said 210, yep, 210 off of Bridgeport, which is approximately, I don't know, maybe here. So, boom, right here. See where these two guys intersected? That's where I am. Now, you're probably like, alright, yeah, that seems pretty easy, but, you know, I have a white piece of paper here. How do I apply that in the real plane? What you have to do is you're going to use these compass roses now. You're going to go down, you go up to Bridgeport here, and look at this compass rose. This says 27 right here. 27. This says 9. Okay. 180 radial. So we said 210 radial. So the way we're going to do that is go to 18. This is 180. This is 190. This is 200. And this right here would be 210. So you trace a line extending from Bridgeport and then crossing through the 210 radial all the way down your sectional. Then you go to Deer Park and you trace the line to, I think it was 200. So this is 150. I think 180 is hidden, but you just got to do the math. 15, 16, 17, 18, 19, 200, and draw the line. Where those two lines intersect is where you are. That's how you find out where you are if you're lost. It's that same exact concept with the 5th Avenue and 53rd Street. Yeah, if you're on 42nd, okay, great. I'm on 42nd Street, but I need to find out one of these avenues, that intersection of those two radials or of those two streets, to figure out where I am. Now, don't think this plane has any other avionics that you're used to. Sometimes we'll see this, right? You'll just see one nav radio. You'll put in, say, Deer Park 117.7. Identify it. You just put it to the right. Here's your volume. Voice means it's on. Okay, so that's another one. I mean, most of the radios are pretty self-explanatory. Yep, same thing here. Here's your comm. Here's your nav 1, nav 2. And yes, so we're mostly just used to the 430. Now, I believe if I can show you airplane nav radio. Some of our planes have some that look like this. So there's 4 frequencies. The first 2 are comm. This is the active comm frequency. This is the standby comm frequency. So active, standby, because the active is the one you're using. The standby is the one that you're listening to. And then over here, nav. So nav active is 110.7. Nav standby is 114.10. This is the dial used to change it. You switch it right here. And this is your volume knob. And this says pull ident, meaning pull it to identify it. And then up top, you just press nav 1 and give it a listen. So, to conclude this whole lesson, I'll show you, and I spent an hour talking about it, I'll show you how to do this stuff very quickly. So, say I want to tune in, let's do JFK VOR. Let's go back to Sky Vector. Let me just take a look at my airplane. I think I'm heading towards the ground. There we go. So, if I want to go fly to JFK VOR, go to Sky Vector, JFK, where is it? VOR DME. Very high frequency, omnidirectional range, distance measuring equipment. 115.9. So, flying along, push it. 115.9. Switch it into active. Okay. Turn my volume up. Push to ID. Press down nav 1 here. Alright, listen for the Morse code. Alright, that's the correct one. Turn it off. Unselect it. Press CDI. Do not forget to press CDI. Twist it until it centers up with the 2 indication. And it tells me that if I fly a track of about 265, I will get there. That means that I'm located on, this is 06, this is 09, sorry, this is 06, this is 9. I'm located on the 085 radial. So if I fly a track of 265, right here, 265, same thing over here on your Garmin 430, 265. This needle will stay centered and I'll make it there. Now, the further you are away from the station, the more sensitive it is. Or the less sensitive, sorry, the further you are from the station, the less sensitive it is. I'm going to show you. I'm going to just fly completely away from my selected radial and watch how it slowly moves away. Because the radial I selected was like here. And now I'm flying away from it. Now because, like I mentioned, because I'm so far away from it, it's going to take me a while, or it's going to take the instrument a while to show this change. And think about it like this. This is what we'll finish off on. Open up Paint again. If this is your VOR and here's your radials, right, when you're really close, the distance between these radials here is like this. But when you're further away, it's like that, right? So distance is greater, so it takes a longer time to display course deflection. Okay, so that is an introduction of how to use VORs. If you have any questions, shoot me a text. I'll be happy to go over them.